So then, number 4, I'm very interested to find out what the questions are for number 4 and see if I'm able to answer them. So I will not belabor the point, but you all need to remember that when finding antiderivatives, you don't want to be on autopilot. You don't want to assume because this is partial fractions that we've been studying, this is partial fractions that we'll be doing. That's only going to take you so far because we will be studying, and we have studied many situations where partial fractions are irrelevant. So if you go into this saying, I'm going to use partial fractions, you have the wrong frame of mind to help you be successful down the road. You want to be thinking more open-minded. If you decide, because you've noticed things from your practice, that partial fractions are appropriate, that's certainly fine. But don't just assume always partial fractions. So with that being said, I am going to try partial fractions here. And that is for a few reasons. Most of them have to do with the math I did in my head, part of which includes noticing that x cubed minus 4x factors like so, which makes me think partial fractions make sense here. Anyway, I'm going to have a 1, a 2, a 3, partial fractions. Shouldn't change anything about how I do it, but let's find out. So we need a common denominator of x times x minus 2 times x plus 2. Man, these partial fraction things are handy. They already tell me the common denominator. And I also know that x cannot be 0, 2, or negative 2. And that's going to come in helpful later. That will be helpful. So what am I going to do? Well, I'm going to partial some fractions. Okay. Didn't know that was a verb, but it is. I'm also going to cheat outrageously. So I'm going to skip like 4 steps of algebra and tell you that this is the equation I'm solving. Oops, I forgot an X on there. I'll put it on the end. It's fine. It's fine. It's fine. Okay, so I skipped a whole bunch of algebraic steps. If you need more of that, let me know some other time. I'd like to stick as much as I can here to the relevant calculus. So our shortcut tells us that we can let x equal 0, x equal 2, and x equal negative 2 in the hope that we'll be able to solve for a, b, and c. Let's find out first if x equals 0. We have an equation that starts with the 0 plus 0 plus 12. We have a negative 4a. 0 minus 2, 0 plus 2 is negative 4. Multiplied together make 4a. B is 0. C is also 0. Nice. A is negative 3. Okay, let's see if we are as fortunate when x is 2. When x is 2, what happens? We have 4 plus 24. Sounds like 28. So 40. A is 0. B is 2 plus 2 is 4. 4 times 2 is 8. 8b. How about C? C is also 0. So that means B must be 5. Last but not least, let's see if we can get C here. If x equals negative 2, we get 4 minus 24 this time. That sounds like a negative 20. Negative 20. So it's a negative 8. A is 0, B is 0, C is negative 2 minus 2 is negative 4 times negative 2 is 8. C then is negative 1. Invest in smart paper. It is the future. That was the wrong button. Don't do that. Someone's got to amuse me. You all can't be counted upon to do that, that's for sure. Okay, watch the incredibly shrinking math. Bam. There it is. Look at that. Okay, so I can take my integrand, which was that, and be this mess. So A, -3 over x, B, +5 over the quantity of x minus 2, C, -1 over the quantity of x plus 2. Those then are the antiderivatives I need to find. They're all natural logs. I will not be simplifying any of these any further with natural logs. Please note that you ought to use the absolute value for all of these, as well as make sure you do the integral equivalent of dotting i's and crossing t's, which is plus c. Without the plus c, you have achieved at most partial credit, and depending on the problem, limited partial credit. Seems like an opportune time to pause. Resuming recording. I agreed to do either 6 or 7. 6 was selected. For number 6, we are told up front to use the substitution u equals e to the power of x. Okay, if u equals e to the power of x, du equals e to the x dx. Now, what then do I do here? And this is probably where the confusion came in. I have du in the numerator, or 1 times du. Then I've got a u minus 1 times quantity of u plus 6. So this then is the thing that I'm working with. And OMG, it's already factored. Nice. So I have 1 divided by u minus 1, u plus 6. I need the u minus 1 fraction and the u plus 6 fraction. Those are the ones that I need. I need a placeholder for each one. The dummy variables will go capital A, capital B. So the question is, what is the value of capital A? What is the value of capital B? So I won't write it out, but I will summarize verbally. We need to solve this rational equation. We need a common denominator, check. We need to know when this is undefined, 1 and -6, check. We need to get to the common denominator, and remember then that the common denominator will be 1 in all cases, which means we can continue solving the equation from there. So that is what I'll be doing. I will be skipping a few steps, but that is the general idea. So the equation I'm solving is 1 equal A times quantity of u plus 6, B times quantity of u minus 1. If u is -6, we get 1. A is 0, B is -7, so B must be then -1/7. If, on the other hand, we let u equal 1, we have 1 and we have 7a with a 0b. A is 1/7. Okay. Look at that. We made some math. Let's make the math shrink. That's fun. It's like the opposite of Shrinky Dinks. Did you ever play with the Shrinky Dink toys? No. Must be something only people my age would appreciate. General idea was you'd color in like a full-sized plastic thing with their special coloring pens, and you'd cut them out, and then you'd bake them, and they'd shrink, and then you'd have made art or something. So Antiderivative I'm interested in after substituting, after partial fractions, is for A, 1/7, for B, -1/7. Both of these are natural log antiderivatives. I will not be factoring or combining or any of those things here because I don't want to, but I could. Trust me. Take my word for it. Have the same math powers you do. That's an e to the x, not an x. Looky, looky. Another antiderivative. Relevant question to everybody before I pause the recording. The question was, will there be partial fraction problems with definite integrals? The answer is definitely yes. They will happen. Let me pause here. Again. Looking at number 11 from the homework, that's what we're doing. Now, you may have partial fractions on the brain, and partial fractions is partially wrong. You need to be active, you need to be attentive, you need to be thorough, you need to be detailed. You don't want to just jump right in because that's what we did in class. That's a terrible approach to doing, well, pretty much anything, but especially calculus. So think carefully here. What else could you use? Could you do arcsine? Nope. Arctangent? Nope. If you don't know why nope to both of those, then you should go back and study those. Could I use completing the square? I could, doesn't help me any. Could I use substitution? I could, doesn't help me any. What I'm going to use here is long division. And you know it is long division when it is long division. No, that's not helpful. You know it is long division when the degree of the numerator is greater than or equal to the degree of the denominator. Now, I like the placeholders 0x squared and 0x. Those are unnecessary. I like them because it helps me stay organized. Entirely up to you as to whether or not you do them. But you do division the same way regardless. X is going to work here. If I remember to distribute, I have x cubed minus x squared. The other big thing we pay attention to with polynomial long division is we remember to subtract down. So that's an x cubed minus x cubed. That's 0. 0x squared minus negative x squared is a positive x squared. So positive x squared plus 0x plus 1. What then do I need to multiply x squared by to make x squared? The answer is 1. Subtracting and distributing, once again, x squared minus x. This is x squared minus 0, x, 0x minus negative x, x, 1 minus 0. Remainder is x minus, I'm sorry, x plus 1. All right, so here's what I have done so far. I have taken the integrand and I have changed the way it looks using long division. So based on all of that, my integrand is now antiderivative of x plus 1 plus x plus 1 divided by x squared minus x. So antiderivative of x is a half x squared. Antiderivative of 1 is x. Antiderivative of x plus 1 divided by x squared minus 1. That was me running through all of my options. That's the sound I make in my head, doing it out loud so you realize I'm doing things. Partial fractions. Partial fractions. So let's partial these fractions right here. I got an x plus 1, x times quantity of x minus 1. Factors are x and x minus 1. Placeholders A and B. I'm going to skip a ton of steps again and say that this is the equation we're solving. Again, the steps I skipped include getting a common denominator for all three fractions, observing that x can be neither 0 nor 1 because that would make the equation undefined, multiplying through by the common denominator so that the common denominator makes 1 for every single term, and we get x plus 1 equals a times quantity of x minus 1 plus b times x. From there, we can use the shortcut or the long cut. We're doing the shortcut. It will work. And it works by identifying the values that actually, interestingly enough, are both undefined for the equation and simplify this equation. So if x equals 1, I have 2 on the left side. I have 0 times a, and I have 1 times b. Look at that, b is 2. If, on the other hand, we're going to let x equal 0 on the left side, yes, 0 is right. Sorry, I was getting ahead of myself. I've got 1. One, a is negative a, b is 0, so a is negative 1. Okay. Let's shrink that down to size here. Zoop. Teeny tiny. So it's 1/2 x squared plus x plus the antiderivative of a is negative 1 divided by x. B is 2 divided by x minus 1 dx, which means I have 1/2 x squared plus x minus the natural log of the absolute value of x plus 2 times the natural log of the absolute value of x minus 1. Yes, even after all that, plus c. Huh. Neat little problem there, if I do say so myself, and I did, so I will.